Hey everyone, and welcome to this formlabs webinar on digital dentistry with desktop 3D printing. Today we're going to be talking about previous technology and future technology that can help speed up your workflow and improve patient care. We also have Dr. Michael Scherer. He's going to be sharing some case studies and also his experience in using the formlabs 3D printer and other digital tools to speed up his workflow and save costs. At the end of the talk, we'll have some time for questions as well. So if you'd like to, if anything comes up, feel free to type it in, and we'll get to it then. So today, we're also really lucky to have Dr. Michael Scherer. He's a board-certified prosthodontist. He's based in Sonora, California. There are less than 1,000 board-certified prosthodontists in the world. So again, very lucky to have him here, sharing his experience and his expertise with us. A little about Formlabs before we get started. We were formed in 2011. You might have heard of our Form 1 Kickstarter back in 2012. Soon afterwards, in 2014, we came out with the Form 1 Plus, and then the very next year, in Q3, we came out with the Form 2, our current flagship product. In Q2 of 2016, we also came out with Dental SG, which is the only biocompatible resin available for a desktop 3D printer today. So on that note, without further ado, I'd like to turn it over to Michael, and let's get started. Michael?
Thank you, Jordan, for being able to present this information, and it's a privilege to be able to show this around the world. I know we have people tuning in from not only here in the United States, but abroad. So this is just a presentation, almost an introduction, as well as some details of some of the desktop 3D printing workflows that I've been using in my office successfully for, give or take the past 2 years. And like Jordan was talking about, I first got started with Formlabs when it was the Form 1 and Form 1 Plus, and I'm happy to show you a lot of that work in addition to showing you some of the Form 2 work that I have. The Form 2 really is a magical 3D printer. Also, he did a nice introduction for me. I'm not going to repeat that, but I am a clinical instructor at 2 institutions here on the West Coast of the United States. And if you have any other follow-up questions that are not answered during this presentation, I'm happy to tender that via email. That's my email address listed below. A couple of disclosure statements. Any of the information I'm presenting in this presentation is not endorsed by any of the institutions that I'm associated with, and fair disclosure, I'm a registered speaker and clinical consultant for multiple dental implant companies, and I also do promote implant dentistry and also digital implant dentistry on YouTube, and that information is seen at the link below. 3M disclosure statement, anything that I present during this presentation is what I do in my own clinical practice, and these are the current cleared FDA indications for the TrueDef scanner. Blue Sky Bio also has a disclosure statement. Anything that they recommend using the CBCT scan and or a laboratory desktop scanner to produce STL files, and the use of an intraoral scanner and STL files generated are not approved in their software protocols. Introducing digital dentistry. What I really like to talk about principally is sort of the rationale of why we 3D print and why we use intraoral scanning in clinical dentistry these days, and it really comes down to this simple fact. While both of these pieces of technology here can display as well as fabricate a document, clearly how many of us would actually want to go back to the image here on the left, where we clearly can easily do word processing on the right. And in many ways, that's true of clinical dentistry today. And there's quite a few practitioners out there still using these classic techniques here on the left-hand side of the screen versus these digital techniques like you see here on the right side of the screen. While both of them are very clinically appropriate, PVS, I certainly will not argue to you, is an inaccurate material. Far from it. It's incredibly accurate. And fabricating traditional surgical guides with surgical planning methods like seen on the left is proven. The years of clinical research clearly indicate so. However, the digital workflow on the right is proven, and the technology is rapidly progressing every day. The traditional workflow clearly has a lot of benefits. It's incredibly accurate. It's been around forever. It has a low initial cost, and it's initially simpler. Whereas the digital pathway is an incredibly accurate process, just like conventional. They're both very, very accurate. However, you get instantaneous feedback, meaning that if I'm unsure of a clinical margin or I'm unsure of the ability of me to capture a proper impression for fabricating a surgical guide, being able to do so with digital gives me an instantaneous feedback that I've actually captured sufficient information versus, you know what, pulling it out of the mouth, looking at it and going, I think I got it, pouring up the model, and then finding out you're having to call the patient back in for a redo. It's comfortable, less stressful, it's faster, and you can delegate to an assistant very easily. Certainly, the number one negative of the conventional analog process is retakes and remakes, and it relies upon stone models. Now, of course, digital. Anytime that we talk digital and modern technology, there's typically higher upfront costs. And while that may or may not be true depending upon the type of technology you like to utilize, for me, I use a very reasonably cost pathway, and I'll explain that in a bit. Now, anytime that you do something for the first time, it's going to be challenging. And let's think about the first time that we prepped a crown, the first time that we did a class 1 amalgam prep. They're incredibly challenging. And the same is true of digital dentistry and 3D printing. While initially on the surface it sounds like something that is too complicated, but in all reality is very, very simple. And certainly labs need to be calibrated, but that's not so much of an issue when you're doing it yourself. Of course, the number one negative of the conventional pathways is having to do remakes, retakes, just to capture margins, like was shown here in this PVS impression. But using an intraoral digital scanner is fabulous. You could really not pay me enough to go back to conventional PVS. I switched over 2-3 years ago with the digital pathway. I have not looked back since. Maybe I pull out PVS once a year to do a crown and bridge impression. Complete dentures are still not there yet. However, we're rapidly approaching that complete digital pathway. But in all reality, I just will not go back, period. Because this is true of what I've seen in my practice, a dramatic reduction in remakes, retakes, and errors produced in the laboratory process, and ultimately increases my predictability and decreases my stress. And I show this slide as an aside because yes, we're going to be talking about 3D printing, but remember, 3D printing is sort of new. It's sort of like, you know what, I'm not sure if I really want to trust a printer in my practice yet. Or maybe I'm a doctor sitting on the fence tuning in here today going, gosh, you know what, all of this sounds great, but do I really want to mess with it? Well, I can tell you that it is an incredible technology, and it's proven. Crowns fabricated from a digital approach fit as accurate or potentially more accurate than conventional PVS techniques. So the moral of the story is that you can take that and incorporate it easily into your practice, not only with the accuracy setting, but showing here the time savings. So in my own practice, it takes me about 5 minutes for every arch of PVS. Now you might be a minute faster than this, or if you're using fast set material, 1.5 minutes, but still it's approaching 3 to 5 minutes. Versus the digital approach, on average, takes only about 1 minute to 2 minutes in my clinical practice. It's really, that's completely true. This is not manufacturer provided data, this is from my own clinical practice. And when you take that in consideration with what you find as a cost savings and you multiply that, or time savings, multiply that by the cost savings of about $5 per minute of overhead time in the average conventional practice in North America, that's costing you $17.50 just for your time for the conventional technique. So yes, absolutely, optical scanning is critical. What we're going to talk about today is using optical scans for very interesting applications with using desktop 3D printers. Now there's two methods that we can generate digital files of a patient's model. Shown here on the left is the traditional digital approach, where me as a dentist, I will go ahead and make a PVS or an allogeneid impression of my patient, go ahead and pour a stone model or cast from that impression, and mail that to my laboratory. My laboratory technician, whether I know it or not, most of them are working in a digital sphere. They're taking that model and they're putting it into a 3D scanner, desktop 3D scanner like shown here on the left-hand side of the screen, and generating a digital file from that. Now I've done that. I don't have a desktop 3D scanner in my own practice because I use what's shown here on the right side of the screen. The intraoral direct scanner of inside the mouth is absolutely critical. I love it, would not go back to anything else. The desktop 3D printer in combination with this intraoral scanning technique is so efficient. Taking this patient, like I'm showing you here, I'm live scanning this patient. I'm scanning the implant post that's inside of here, and I'm generating a digital file of this patient's quadrant. By doing that, it's giving me instantaneous results. When I take my wand and I start hovering it over teeth and oral structures, such as tissue and palate, it allows me to capture that digital file that you see. And instantly I can take my fingers, manipulate it, and make sure that I've sufficiently captured everything completely around. Now, once I've captured that image, the magic occurs in the scanner itself. Depending upon which type of scanner you've seen out there, or if you're new to intraoral scanning, most scanning companies within the unit will allow you to export a file. But that file is called an OpenSTL file. An STL file stands for stereolithography. Sometimes there's some things out there called a backronym that's also called standard tessellation language, or there's a whole other backronyms associated with it, but it means stereolithography. And that system allows me to also give the option, if I don't really want to mess with this STL file, this three-dimensional image, and hack it myself or 3D print myself, I can fit it in with my conventional workflow. Just send it to my lab technician, like here in the bottom right, or I can send to any technician via one of these three main dental softwares down here on the bottom. What we do, though, is we take that image file that's generated from the three-dimensional intraoral scan, and the magic occurs when I go ahead and I go to the OpenSTL pathway. And that STL file allows me to do a whole host of different really cool dental applications with it. And the ultimate goal there is to be able to fabricate either models or directly fabricate surgical guides, or potentially in the future directly being able to fabricate intraoral restorations. And this OpenSTL pathway is essentially taking my intraoral scan and exporting a three-dimensional file. And that three-dimensional file is an STL. And while that might sound confusing at first, remember the first day that somebody told you, hey, I'm going to send you this picture of me on vacation, and it's in something called a JPEG file. And you go, what the heck is a JPEG or a GIF file? And it's many ways the same thing. A JPEG file is a two-dimensional picture, and an STL file is a three-dimensional picture. Now that intraoral scan converts to the OpenSTL file, and by taking that OpenSTL file, I can then superimpose it on a dental CBCT scan. By superimposing it or image fusing it to the CBCT scan, I'm able to generate conventional surgical guides. And the conventional surgical guide pathway and process is pretty well proven in implant dentistry. As we see here, this is a very conventional surgical guide approach using the Anatomage software. It's excellent, very effective, works very nicely. Additionally, I can take that and I can also do that with my full arch edentulous patients. So, yes, I can do that with people that have natural teeth, but I can also do it with people that are missing all their teeth. By using this very clever method that I published in a variety of different places, but principally Journal Prosthetic Dentistry, you can make a radiographic scan of a patient wearing a polyvinyl siloxane that is radio opaque. By doing so, I'm more or less relining the inside of the complete denture, doing a trimming, placing this back in the patient's mouth, doing a CBCT scan of the patient, then removing the denture, doing a CBCT scan of the denture alone. In addition to that, I can take my intraoral optical scanner, scan the intaglio surface or the undersurface of the complete denture, and then generate an STL file from that. If I don't have an intraoral scanner, I can use a desktop traditional scanner and fabricate this guide, what you see right here, this model. By taking that, I can also easily remove that radio opaque PVS, and as a result, take that STL file, also superimpose it on top of my three-dimensional dental cone beam scan, and fabricate a surgical guide from that. And those are the established workflows. This established workflow is really proven. Now I'm going to segue into in-office 3D printing. So the whole point of me telling you all of that background information is that all of the things that I'm going to be describing in this next section are proven methods. The methodology is established, it's well proven, well studied, and very, very accurate. So when I take that existing information, whether desktop scanning, intraoral scanning, or conventional surgical guide printing, I can apply that to a formlabs printer. By doing so, I can take that intraoral scan and directly fabricate dental models and restorations in the method of a surgical guide. What's shown here is the formlabs Form 2 printer. As I've mentioned before, I've been a formlabs printer user for years now. I started out with the formlabs 1 Plus because I thought this was a really cool technology. I spent hours researching 3D printers, and I came up with the conclusion that in dentistry, those fused deposition printers, or FFM printers, like what you would see at Costco or at the toy store, where you 3D print where it shoots out material out of a nozzle. I'll show you a picture of what they look like. Those types of printers are really cool for printing toys and little gimmicky type objects, or even just for little engineering projects. But for dentistry, I need something that produces a model like shown here on the bottom left. This is the first model that I ever printed with a formlabs printer. I literally did nothing other than cutting away some of the excess around the tissue that's shown here and just cutting the model off and directly printing this model. This is my first print, and shown direct out of the box. I unpackaged the printer, put it on my desk, and literally put that file in and hit print, and that's what I got. That's the type of image clarity that we need in dentistry. We can't mess around with risking print failures or little areas of funny fuzz around the edges of teeth. I need something that's consistent, clear, and proven. And SLA, or resin SLA printers, are the way to go. Looking at that traditional hobbyist type printer of what's shown here on the left-hand side of the screen, all of these are really nice printers. They're cool, they're fun to use, but they're toys. They're really, meant for playing around or just getting a generalized object of it. Yes, they're clean. Yes, they're simple. Yes, they're easy. But for dentistry, we need something that's a little bit better. What we talk about is something called a desktop 3D printer. I sometimes call these prosumer, even though a lot of times people don't like this term. But in all reality, if you look at the research out there, these types of printers are called consumer printers, but they're really called desktop printers because they sit on a desktop and they're really well designed for professional use at the desktop level. And you can see the price differences can really vary between the basic as well as the high-end versions of these desktop 3D printers. What you're most likely familiar with, or what you see here on the right side of the screen, these are called industrial 3D printers. They're used in dental laboratories, or they're used in 3D printing manufacturing. And the costs of these printers can become extreme. While all of these printers are excellent 3D printers, I will not tell you any of the printers that you see on the right-hand side of the screen, or heck, anywhere on the screen, are anything less than good 3D printers. But the magic is that you look at the price differential. How many of us in our clinical practices are going to afford something in the $150,000 range and up? You know what? Yes, we probably could stretch our budgets and do that, but to tell you the truth, do we have to? So we thought, you know what? $15,000 to $85,000, if I'm really printing a lot with 3D printers, I could probably justify that price. But you know what? I still held off on it because at that price point, I have to have a real business model for being able to use 3D printers in clinical practice. Meaning, am I really going to print that many surgical guides to justify a $20,000 printer versus what you see here on the left-hand side of the screen, the formlabs class, the desktop class, at $3,500, I could justify the cost of my printer in just printing 10 surgical guides. And for me, the math really added up. The lack, however, at the time is when I first got involved with formlabs, it was still kind of like, well, we're using it in dentistry, but we're kind of not using it. Yes, there are a lot of dentists using the Formlabs original printer, but, well, we're not sure how to use it then. When Form 2 came out, I was so excited because the improvements of the Form 2 was not just an evolution, it was a dramatic evolution of desktop SLA printing. With the advent of a heated resin bath, not to mention a lateral peel process and a wiper blade, oh my gosh, it makes 3D printing at the desktop level so simple. And I encourage you, if you want to see the differences of those two, just go to the Formlabs website. As I mentioned before, this is what many of us think of 3D printing. We think of this device that spits out a softened plastic, and it's called a filament. It sits in a spool that sits on the side of the 3D printer, and it coils through this little extruder process. That nozzle is heated and it spits out the resin. And now watch, as this thing prints, the whole print is moving on you. And there's all of this fuzz around the side, and just, you know what, if I want to get something that just kind of gives me an idea of a shape of an object, sure, that'll work. But in all reality, we need something like this in clinical dentistry, where I can take a liquid box and shine light from underneath, and that light will solidify the resin that's on the inside of it. And to be able to print something at such a high resolution and clarity, like shown here on the left-hand side of the screen, I'm actually 3D printing a whole dental implant that's sized 200 times of what it should be sized. And this process is really refined. The laser source sits at the back of the printer, and it goes through a series of mirrors that focus it in different positions on that resin bath. That platform actually goes inside of the liquid inside of here, and it builds vertically and upside down. It's really, really magic. Many of us are also familiar with this type of technology, which is a proprietary 3D printing process in clinical dentistry and laboratories. It's an excellent printer. It uses a very similar method of what has been shown before, except it's proprietary. It's only available from this particular 3D printing company. Excellent 3D printers, but the price point is extremely high. So let's think about the price point, because the price point for us in dentistry is critical. If I'm looking at the scanning, printing, and software pathways and workflows, what you see here on the left-hand side of the screen, I get it. These are wonderful, proven technologies and are incredibly sophisticated. But at that price point, I held off for a while. I said, you know what? My conventional PVS or my conventional lab fabrication methods, delegating, outsourcing, is working perfectly fine. I really don't want to spend that money. Versus the workflow shown here on the right, which is the workflow that I use in my own office. Now you can see $18,000 to $20,000 difference, or pardon me, that's the price point, versus $50,000 to $100,000. That's not just a small difference. That's a colossal price point difference. And there's always what's called sneaker fees that come in. As soon as you've got the paperwork in front of you, you're buying, finally, after all this time, you're buying this 3D scanner, it's going into your office, you're buying this printer, and they go, oh, by the way, you've got an extra $3,000, $4,000 a year in an annual fee just to maintain the darn thing? Oh, get the heck out of here. And those are really sneakers. They come in at the end, so be careful. I'm going to also tell you that 3D printed models from digital scans show an incredible, promising accuracy, but most importantly, they have an incredibly high degree of reproducibility. And this is proven in the orthodontic literature. And orthodontists really embrace digital scanning and 3D printing. Also shown, while the research is relatively new, that's very, very emerging and exciting information that's coming out. And what they're showing is that the desktop level of 3D printer are producing models with high accuracy within 20 to 25 microns of industrial grade 3D prints. So the point of me showing you this is a justification for looking at desktop 3D printing in your practice. It's proven. The research is really emerging, showing that the accuracy of these prints is incredible. And the fact that you can get a 3D printer for $3,500 versus $80,000 and yet still can get a print within 25 microns of difference, wow. That's really what got my attention. So I'm going to propose to you what I use in my practice. This is an in-office workflow for using 3D printers, just some cases as well as some ideas, just to kind of start the thought process for you while you're sitting there across the world saying, gosh, should I really get involved with this? And I've published a couple of articles on this. Here's a couple of the links down below. You're always welcome to check out my website, michaelscheerdmd.com, and I've got links to these articles you can look at. Where I first started in my practice was something so simple that I said, you know what? I'm just going to test this thing. I'm just not sure if this is actually going to work well. So what's the most benign thing I could possibly think of starting with? Making a bleach tray. So I had a patient that said, you know what? I want to take out my lower front incisors. I want to do some crown and bridge work. I want to get rid of these things, but can I bleach before I do that? Absolutely. She said, but I'm so terrified of that goo that you're going to be putting in my mouth. Just let me know when it's coming. And I looked at her with a wry smile and I said, don't worry, I'm going to scan your teeth. And she said, wow, that's incredible. Really? I don't need to use the goo? And she was that excited. So what I did was I intraoral scanned her teeth. And then in open source, freely available modeling software, I built a model and a base for her teeth and actually extruded spaces to hold the bleaching material in place. I 3D printed that model, did a vacuum form on that model, and created a very simple bleach tray. Very, very easy. Taking that original same scan, I can then take it, modify it, basically click undo, go back to the original file, be able to actually design it so that way I can print a model, do a quick vacuum form template over the top, and make a provisional or temporary crown and bridge from that original model. And keep in mind, this was with the original Form 1 printer before I had biocompatible materials to use in the mouth. So this was a workaround because the gray resin materials are not something that I want to use in the mouth. It's not approved. So I need to have a workaround. I know that if I use a vacuum form template that's FDA approved, I can then use that in combination with a 3D printed model to be able to do 3D dentistry. Same patient, after she's healed from the extractions, I can use my intraoral scanner with predictability, being able to fabricate this long span fixed partial denture restoration. My goodness, it fits like a glove. Now granted, she never bleached as well as she hoped for, but as soon as I tried this in her mouth, I said, honey, I don't think I like the shade on this. It's too bright. She goes, I love it. I'm going to bleach. I want to go to that color. That's perfect. And I said, okay. It made me very happy because I didn't have to send it back for ceramic work. But with 3D printing, desktop 3D printing, combined with this industrial grade 3D printing, I was able to validate the workflow and the process in my office. Continuing on, I found out that the formlabs printer allowed me to integrate 3D printing into my everyday clinical workflow. So taking this patient, which would be a challenging final impression, because of undercuts and locking it in and a full rehab patient. My goodness, that makes me nervous. But with 3D intraoral scanning combined with desktop 3D printing, I was very easily able to work this into my existing complete denture workflow, like shown here on the bottom. More challenging, complicated cases. As a prosthodontist, I see a fair number of obturator patients where I have a patient that's missing a part of their upper jaw due to cancer or due to a variety of different reasons. But this patient came to me needing a full mouth rehab, so I did the crowns shown here on the screen, ultimately to get ready for this partial denture that's shown here on the bottom right. And I said to myself, can I use a 3D workflow? Because taking and making an impression of that patient, I actually have to be careful not to place impression material inside of that gap space, because what you're looking at in that hole is actually her nose. That's the air pathway of her nose. And if I get too much impression material in there, I can actually suffocate the patient. So using my intraoral scanner, I was very easily able to scan this patient and to fabricate a metal framework to fit for this patient. Magic. No, reality. In combination with my lovely wife, Dr. Melissa Schotel, shown here on the bottom left-hand side of the screen, she is a trained orthodontist here, practices in Sonora, California. And long story short, she had a patient who was 11 years old, and she said, oh my gosh, I've got her in braces. I don't think I can improve her smile. She's going to need some veneer work, Mike. Is there any way that you can see her and just do something temporary for her? And I said, wow, an 11-year-old patient. It's a little young for me, honey. I said, but I'll be happy to take a look. So I saw her, the braces were removed, my wife set them up in the ideal position for me for cosmetic work. And what I knew is that an 11-year-old patient was a little too young for me to do direct veneers on. So I said, okay, I'm going to make bonding. I'm going to just take some composite filling material, white filling material, and place it on the fronts of these teeth and do an aesthetic bonding for this patient. But the traditional workflow would be to make an alginate impression of this patient, an 11-year-old patient. How much do they love alginates? No, they hate it. And then to take that alginate impression, pour it, and make a stone model from it. By doing that, I make a stone model and I apply wax directly to the model. And long story short, it takes hours to do that. Yes, I can delegate that to a technician. But if I can 3D scan her teeth in a free open source modeling software in about 15 minutes, I can wax up aesthetic teeth for her. An hour later, after printing on my formlabs printer, I've got models I can print with. Making a quick putty shim, like shown here on the bottom part of the screen, I can use it as a method for directly fabricating composites and as a template for me to work in her mouth. Simple, easy, effective, and cost-effective. And the workflow works. Why would I not directly 3D print this shim, this putty? Well, I have to worry about biocompatibility. Yes, with Dental SG, this is an option to do these days. However, this was before Dental SG. And still, this process is very easy to do with a conventional workflow. This patient I saw just Monday of this week. What I had was I had a patient with this large anterior diastema. He says, gosh, I just don't like this thing. Could I do braces? Could I do braces here? I had him see my wife, Dr. Schotel, and she says, no, I don't think this is a good braces patient. His roots are too short. Could I do something that will improve his quality of life very conservatively, very effectively? This is a classic veneer patient. Again, just like the young girl that I showed you here before, the only difference is that what I want to do is I want to show this patient an idea of what I can do with veneers before he commits to the financial investment of the veneer work. So I scanned him, I scanned the patient, and I took his scans, like shown here on the left-hand side in the middle, and I 3D modeled closing that diastema or that space. And I also modeled the teeth on the bottom. And what I did was using the same pathway, I 3D printed the models, upper and lower, and I made a putty index over the top of those models. In about 2.5 minutes, the putty was set. I take my impression, pardon me, not my impression material, but my ProTemp or my provisional temporary crown and bridge material, fill the inside of that putty matrix, sit it on top of the teeth, and I get what's called a mock-up. The mock-up allows the patient to preview what his future smile can look like. As shown here on the bottom side of the screen, this patient loved it. He said, oh my God, can I do this now? And I said, absolutely. And we went forward and did treatment right away for him. Now, as we venture from conventional prosthodontics or cosmetic dentistry, restorative dentistry, let's talk about implant dentistry. As a clinical instructor at 2 institutions, Loma Linda and UNLV, I work with a lot of students. And part of what we start with in implant dentistry and implant surgical techniques is we start with one of these styrofoam fake mandibles. These mandibles are not ideal. They have bone that's 10 millimeters wide. It's incredibly soft. It gives you a mechanical idea of how you work with implants, but very little realism. And I took that approach that we work conventionally in education, and I said, gosh, could I 3D print an entire mandible where students can learn from drilling on an actual patient's mandible, showing you the challenges of a facial undercut, knowing the anatomy of the mental foramen and the distances that we have to stay away from that, knowing the challenges of angulation. The answer is yes. I was able to take that 3D modeling software, design the patient's mandible, so that way it'll feel just like type 2 or type 3 bone in different areas, work that into the UNLV CE department's education course and with students. And you can actually place implants on the formlabs gray resin. And now the magic of this is I can take this, and this is an actual patient that we demonstrate surgery on the day after. So the students are working in a laboratory environment shown here on the right-hand side of the screen. They're experiencing the challenges of simulated jaw surgery. And then when we go to the mouth in collaboration with Dr. Andy Engel at UNLV, when we go to the mouth and they see how we work around those implant surgical problems and challenges, and we correct them using the information that we showed in our training course, the education connection is magic. This is a real live patient that we've treated using the gray resin as a way to practice the implant surgery before going to the live surgery. And we display this live. And the magic of this is excellent. And as a present, just for fun, we always give our patient their own mandible with the implants in position to either show their grandkids as exciting or to scare their grandkids, depending upon what you are in the mood for. But the magic here is it makes the educational connection. Now, when we think about everyday implant dentistry in our offices, many of you are tuning in because you say, gosh, I've heard that Formlabs has come out with this amazing dental SG resin. And yes, dental SG resin allows you to take conventional optical scanning combined with CBCT scanning, and with free dental implant planning software, you can integrate those scans and also your implant plan to be able to directly fabricate and 3D print a biocompatible surgical guide. Showing you here on this screen is a 3D printed full arch surgical guide for the resin cost of $4.22. The total surgical guide cost, including the tubes plus the one export fee that's in the software, is about $15, give or take. The total cost of this guide shown here is only $30. Wow. Compare that to somewhere between $250 to $750 for a conventional surgical guide process. Incredible. It's a game changer in implant dentistry. And I can tell you, after doing probably 20 of these surgeries so far, the accuracy and the fit of these guides is incredible. And you'll notice that this guide, I'll go back one, this guide has a few different colors changes. What's magic is that with the Formlabs biocompatible resin, the only resin that's biocompatible at this price point, it is printed yellow. It comes out of the printer yellow. When you clean it in alcohol bath and put it into a UV cure box, it turns this transparent or translucent amber orange color. Before UV curing, I slide those guide tubes and they just snap into place. When it's UV cured, everything is hard, solidified, and perfect. If I wanted to, I could break off those little print supports on the bottom. I use a disc with a lab handpiece in my practice. I can then easily just say, you know what, I'm going to put this through ethyl alcohol for 15 minutes and let it sterilize. Excuse me. Or Dental SG allows you to take that surgical guide, put it into a sterilization pouch, into an autoclave, believe it or not, and sterilize the guide. The autoclave process changes the color of the guide from amber to this clear color. Wow. I've never heard of this before. It's incredible, and I can tell you it works. The accuracy, the precision, the methodology is incredible. But what about full arch guides? Teeth are easy. Full arch, can we do that? Using the conventional pathway that I just showed you, the green mousse technique or this radiopaque PBS technique, which I've invented, this technique here allows you to take this impression, overlay it into a planning software, a free planning software, and then 3D print a tissue-supported full arch surgical guide for the cost of about $40. Holy Moses. Now, when you take that, you can then run it through your sterilizer with precision, simplicity, and ease, and patient satisfaction out the roof or through the roof. You can place dental implants. As shown here, this is a Zest Locator RTX case. I do a lot of overdentures, almost a pathological amount. Ultimate precision and simplicity. So as we start to wrap up this webinar, what I also want to show you is this is really, really cool. We just finished the first in the entire world, a desktop intraoral 3D printing surgical guide fabrication course using not only intraoral scanning and modeling, but optical scanning with a cone beam to use with the approved pathway with the free software. We successfully hosted this pioneering course last weekend, where we had a large group of doctors actually learning how to model in 3D, how to work with formlabs printers, how to work with gray resin to produce models, and then also how to work with dental SG, biocompatible 3D printed resin, to be able to directly fabricate their own surgical guides. The reception from this course was amazing. The feedback was transcendent, and I encourage you, if you're interested in this pathway, we have 2 additional courses coming up. One of them is almost already sold out, so if you're interested in coming to California to learn about this pathway, I encourage you to go to the website listed down below. As we get towards the end of this presentation, I'd just like to go ahead and thank Formlabs for being able to present it and host this webinar session. And I certainly thank everyone from tuning in from not only here in the United States, but worldwide. I certainly encourage you to visit my website listed down here below for more information, publications, YouTube videos. I've got a 3D dentist website where you can go on and learn some of the basics about modeling with the software. In addition, if you have any questions that are not answered during this question and answer session, I encourage you to send you an email down below. And again, I'm going to pass this on over to Jordan, where we're going to take questions. Thank you very much.
Oh, awesome. Thank you, Michael. That was really interesting. Before we get to the question and answer part, I'm just going to talk a little bit about, the Formlabs printer. You already went into it in great detail, so I'm not going to spend too much time on this. I know people have some questions that they want to get answered. The biggest difference, but there's several differences between the Form 2 and the Form 1. Some of the biggest ones you've already touched on, but we really like to talk about how we've improved the optical path. We've increased the amount of the ability to connect to the printer. We made it a whole lot easier to get to use it in an office setting. And just in general, we've improved it in almost every way possible. So moving on to preform, that's also continuing to improve. We've added a one-click print function. So now you can simply import your model, press one button, and then a second button to send it to the printer. That's all it takes. Ever since the Form 2 has come out, we've increased our material library by a significant margin. We have several different materials that you can see here. Dental SG itself, you can see on my screen the cost savings that come with having an in-house machine or even having a desktop machine. If you send something out to a lab, it's going to be more expensive than both in-house and an industrial printer, but even with the Form 2, you're going to get a lot more bang for your buck. We also have a wide variety, like I mentioned before, but a wide variety of materials. Here's a bunch of different uses that you can do with it. Someone in the questions actually asked us if you could do metal casting with the Form 2, and the answer is with the castable resin, yes, you can. So we're very proud to have that as an offering as well. So if you guys would like to take a look at some more detail, we have a white paper available online. The address is here. You can also contact us if you're interested in purchasing. I'm going to leave it on this next slide. You can copy down this info if you'd like. If you have any questions about this webinar or future webinars, you can talk to me, Jordan at formlabs.com. And we also have Zaid. He's our customer development manager. And if you have any questions about integrating into your workflow or anything like that, it can also help you with purchasing as well. So to jump into some of the questions, one of the first, and Michael, this one's going to be for you, is a lot of people have asked what sort of software, what the name of the software you used was, and what the name of the scanner was, and as well as the price point for both.
No, those are very good questions. Thank you, Jordan. Long story short, the name of the scanner that I use is the 3M True Definition Scanner. The retail MSRP of that is $15,995, or right around $16,000. The software packages that I use a host and a variety of software packages depending upon the indications. Now, you can use traditional dental-specific software packages like Dental Wings, 3Shape, or ExoCAD. However, those software packages usually run in the neighborhood of $6,000 to $20,000 with annual maintenance fees between $1,500 to $10,000. Those are dental specific and allow you to just kind of click, add a tooth, click, make a base, click, do the things that you need to do. Long story short, I use free open source CAD engineering software, things like Blender, also software like Autodesk Mesh Mixer, also use software called NetFab Basic, and Google SketchUp. There is also software out there that's available through modeling for rendering software, things like Maya. However, those things don't work as well in the dental sphere or dental world. The software that I use for designing surgical guides is called Blue Sky Plan, and it's a free software that's available from Blue Sky Bio. It's a dental implant company, and they also allow direct exports of the surgical guide plans. They're approximately, they do have a click fee. That's one way to justify the cost of giving away the program for free. The click cost per guide is somewhere between $10 and $20 per STL export, depending upon how many of the STL exports you purchase. That's something to consider. However, there is also software that you can purchase that will allow you to do that. One of the software packages is called Co-Diagnostics, and that software is available in combination with the Dental Wing software or separately. It's approximately $6,000 for that software, and they have an export fee of about $60. Many people are also interested in the Implant Studio software from 3Shape, and the going price is somewhere between $6,000 and $8,000 for that software, and that's just kind of giving you a ballpark. So the software cost can become extremely expensive and harder to justify in the long term, hence why I use free and commonly available dental software.
Awesome. So a couple other questions we have here. How long does it take to print a full arch in Dental SG? That's from a user who actually already has a Form 2 on his way. Michael, could you elaborate on that, please?
Absolutely. It really kind of depends upon if you're doing all of the teeth or just doing the tissue, etc. As a rule, a quadrant, if I'm only going to do a couple of teeth on either side for Dental SG, it usually takes about an hour and a half to print one of those. To 3D print an entire arch is probably about 2 to 2.5 hours, somewhere in that ballpark. And the reason for that is that Dental SG is really only rated to be print at one resolution, which is a very high resolution. Unlike the gray resin you can choose from either 25, 50, or 100 microns to 3D print. And a typical model arch of a patient, a full arch that has a reasonably sized base, is usually about an hour, maybe hour to an hour and a half to print.
Okay. Michael, could you repeat just the last couple sentences that I'm afraid I spoke over you? I'm sorry about that.
Not a problem. As I mentioned, the Dental SG for just a quadrant takes about an hour to an hour and a half to print. For a full arch, somewhere between 2 to 2.5 hours. For the gray resin, which is the model resin for using with teeth, if you're doing one of the three resolutions, though if you're doing the 100 micron resolution, which is what I normally do, it usually takes about an hour to an hour and a half to print a full arch of teeth.
Okay. What about the post-curing time in the process? And there's a second question in that is, can you put the formlabs resin, the dental SG, someone is asking which resins you can put into a autoclave without deforming or changing the model. The answer to that is the dental SG is autoclavable. However, the other ones, it may warp the part. So the question I asked earlier was, what's the post-curing time and process involved with the dental SG?
So dental SG usually requires, well, all the resins require an alcohol bath. So typically what I do is I place the model or the print, the SG print, into a isopropyl alcohol bath ×2, meaning I have it in one bath for a couple of minutes, and then I put it into a second bath for another couple of minutes. And these baths,
Yes, sir. How you doing?
Clearing stations will come in what's called a finishing kit.
4 minutes.
The finishing kit comes with a 3D printer, and you don't really have to worry about how you do it. After the resin bath, I then air dry it off using my dental airline, and then I put it into a UV cure box. You have a couple of options. You can put it into a traditional triad machine for about 10 to 20 minutes, or you can put it in a LC 3D light curing box, which is available. You just contact the formlabs company. They'll give you the location of where to look to get that 3D printing box. Reach out to them, and it's a cure box that you put the dental SG into for somewhere between 50 to 60 minutes. It's a low-level, low-intensity curing machine compared to the triad machine, and it's a lot more gentle of a curing process versus the triad. I've successfully cured them in both of them. However, in the triad machine, sometimes you get some warping of the print, so you want to be careful with that. After that's been done, you put it into the or you cut off the supports. You put it into the autoclave. It goes into a standard autoclave on the bagged setting, like in a Statum machine. And it's 134 degrees Celsius for 5 minutes. Once it's done there, it gets open the day of the surgery, and you try it in on the patient. Now, what I do like to do is that I also like to 3D print the model of the patient's teeth to validate the fit of the guide in the yellow as well as the amber state. As long as it's fitting during the amber state, I feel very comfortable with just leaving it in the sterilization pouch the day of the surgery.
We also have so we got about 8 minutes left, so we have some time for more questions. But the next one is awesome question. What is the cost of the gray printed model per arch, and are you able to edit the model like wax? Are you able to edit the model like a wax mock-up prior to printing, or do you rescan the model after the wax and then print that?
Oh, no. Everything is done ahead of time. The magic is that when you understand some of the basics of how to work in clay modeling tools, like in Blender or Mesh Mixer, these are seemingly challenging programs at first until you really just sit there and play with it a little bit. It's very simple. If you ever get confused, you can always just do a Google search. There's plenty of little tutorials out there on how to work with these softwares, or you can certainly attend one of our courses. We'd be happy to teach you in person. So I always, like in that one patient I showed you where we did the anterior composite mock-up, what I did was I took that original file, brought it into my software, and actually waxed all of what I thought was the ideal teeth. So in the software packages, you have like smoothing tools, you have like drawing tools or inflating tools. It's all basically to enlarge the parts of the tooth model, the digital model. By doing that, it's virtually waxing on the teeth. It's very simple, very sophisticated. In the software, you can also extrude parts of the model to build the base, et cetera. So I generate a waxed up model, export that STL file, bring it into the preform software from Formlabs, and then put it on the build plate or build platform. And then what I also do is I then export the original model just to compare. Part of what I do with patients is that after I do something like this, it becomes a cool marketing tool. So I'll actually give my patients their own teeth 3D printed, and I even have little toys that I 3D print for them. I've got a little rubber ducky that I 3D print for them. I 3D print a flower for a lot of my older female patients. There's a lot of things that you can do that's very compelling. Now, to answer the first part of that question, which is how much does the resin cost? The average dental arch costs between $1 and $3 to print. No joke. $1 to $3. And that's compared with some of the other professional or industrial grade 3D printers, like what you saw on the slide that I showed. Many times their per arch printing fee starts at $15 and goes up from there. The cost differential is huge, not only the printer, but the resin itself. So the gray resin runs 14 cents a milliliter because it comes in a 1,000 milliliter cartridge, just like your inkjet printer. You pop in a cartridge, it's ready to print. You don't have to touch all this stuff. It's very simple. There's no messy anything. It's very, very simple to use these things. At 14 cents an ml, the average dental arch is probably about 10 to 20 milliliters to print, so you can do the math from there. Dental SG runs 40 cents an ml because Dental SG sells for $399 for a cartridge of 1,000 milliliters. At 40 cents an ml, the average surgical guide is, like I said, approximately 5 to 15 milliliters.
Okay, so there's another question we have here. Orthodontist office. In my office, we use our formlabs printer for indirect bonding. Do you or your wife know of any other applications for orthodontists using 3D printers?
Oh, absolutely. Indirect bonding is a fabulous way of using 3D printing in an orthodontics office. There's also software out there that lets you directly 3D print your own clear aligners, very much like the conventional pathway of the clear aligner pathway. What you can do is you can do it in one of two ways. In modeling software, you can actually move teeth around yourself and then directly fabricate step-by-step protocols of being able to move teeth with clear aligners, just like that one younger college student reverse engineered an amazing process. I give him a tremendous amount of kudos because he was able to reverse engineer orthodontic movement of his own teeth with knowing basically nothing about dentistry. So if he can do it, we can all do it. And the magic here is that with that pathway, what you can do is you can move teeth and get them to shift and print models in succession of what the tooth movement should be. If you don't want to hack it yourself or use the open source software, there is a software out there called Orchestrate, and it's actually a fabulous software designed by an orthodontist that lets you design your own clear aligners, a very simple workflow, and then to 3D print all of the models associated with it. So at this current time, you cannot directly 3D print your own clear aligners because there's a lot of biological pathways involved there and clearance regulatory issues, but the way that the major companies do is they just print a series of models, either 10, etc., of how many aligners you need fabricated, and they just do a vacuum over the top. And they do a vacuum in a polypropylene or polyethylene vacuum form material, just like what we would do for making bleaching trays or for making like a temporary aligner. You can do in your own practice. You 3D print the models, you process them, clean them, and you put them in your vacuum machine, and that's how you fabricate them in an orthodontic office. In addition to that, you can 3D print your own direct study models that you can show a patient. Imagine how cool it would be to show their own teeth 3D printed in combination with the digital models that you show on the computer screen. And marketing in a 3D office is huge. Patients love modern technology, and I use my formlabs printer almost as much just to market for my patients and to say, wow, we're like really cutting edge, almost bleeding edge in my practice, and it makes your life easier. You don't need the impression glue, you don't need all that stuff, and with a younger population, it's really, really exciting. So being able to 3D print a toy or being able to 3D print something for your patients as a giveaway in your practice for coming in as a new patient, I do all those things, and it's really, really fun.
So we have just enough time for two last questions. The first is, we've gotten a couple ones about this, is when you take a cone beam CT, the bone image is in DICOM format. How do you convert DICOM format to STL? And then the second one is,
Go ahead.
The second one's just a short one. It's where do you get and the cost of them? Where do you get the metal rings and what's their cost? So you can take those in any order.
Okay, perfect. I'll start with the first one. So modeling the bone is actually pretty simple. You can do that in a variety of software packages that allow you to do that. But basically what you have to do is you have to threshold the bone correctly, meaning that in your software, you're actually having a slider that goes across that will tell the computer software the shape of the jawbone structures. All of the laboratories, that's what they do for modeling and 3D printing bone and jaw structures. You can do that in the Blue Sky Plan software. It will let you do that. You can also do that in a program called Osirix, which is on a Macintosh computer. That's a software package that's free and open source. And there's a whole host of different software packages out there that let you do it. Second question is where do I get the guide tubes for the guided surgery? That's also available from Blue Sky Bio. They sell them directly on their website. If you just go to Google and type in Blue Sky Bio guide tubes, you'll pick up the webpage to do them. They usually run between $5 and $6 a guide tube, and that's how you get to the cost of $20 to $25 for a single implant guide, because you have a resin cost of about $2 to $3. Then you have a guide tube purchase of about $5, and then the STL export costs, which is somewhere between $10 and $20, depending upon how many you buy.
Awesome. Okay, so that's it for the time we have, guys. I'm sorry we couldn't get to all your questions. If you do have further questions you'd like to follow up, you can reach out to me, and I can reach out to Michael, or you can reach out to him directly, or you can reach out to Zaid for more information on integrating the the Formlabs printer with your current workflow. But again, I want to thank everybody for coming, and especially thank you, Dr. Scherer, for spending some time with us. And I'd like to, just have a great day, guys, and happy printing.
Thank you. It was a pleasure.